Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In radical halogenation with Br, bromine radical is highly selective. It preferentially abstracts the hydrogen that gives the most stable, lowest energy, carbon radical. The stability order of radicals is tertiary, secondary, primary, and radicals are further stabilized by adjacent heteroatom lone pairs, alpha-2 oxygen, or other stabilizing groups. Moving on to the next step. Identify each hydrogen and the radical that would be formed upon abstraction. HA, this hydrogen is on a carbon that also bears a CH3 group. Looking at the structure, HA is on a carbon at the top of the ring that has a methyl group attached. The carbon bearing H appears to be a tertiary carbon, part of ring plus methyl substituent plus 2 ring carbons, giving a tertiary radical upon abstraction. HB, this hydrogen is on the carbon bearing the OH group, alpha-2 oxygen. Abstraction gives a radical alpha-2 OH, which is stabilized by the adjacent oxygen lone pairs. This carbon is also a secondary tertiary ring carbon alpha-2 OH. HC, this hydrogen is on an exocyclic CH2 group, primary carbon, giving a primary radical, least stable. HD, this hydrogen is on a secondary ring carbon, giving a secondary radical. Moving on to the next step. Determine which position gives the most stable radical. HR is on a carbon that is tertiary, connected to the ring carbon on one side, the ring carbon on the other side, and the CH3 group. This gives a tertiary carbon radical. HB is alpha-2 OH, secondary or tertiary ring carbon alpha-2 oxygen, stabilized but lightly secondary. HA gives a tertiary radical, which is more stable than the secondary radical from HD, more stable than the primary radical from HC. And for the final step, compare HA, tertiary radical, versus HB, alpha-2 OH, secondary radical. A tertiary radical is generally more stable than a secondary radical alpha-2 oxygen in most cases, and Br being selective will favor the most stable radical. The carbon bearing HA has 3 carbon substituents, 2 ring carbons plus 1 CH3, making the resulting radical tertiary. Why other options fail? HC gives primary radical, least stable, least favored. HD gives secondary radical, moderately stable, but less than tertiary. HB gives a radical alpha-2 OH, secondary, stabilized by oxygen, but tertiary carbon radical from HA abstraction is more stable overall. Therefore, Br most readily abstracts HA to give the most stable tertiary radical. Therefore, the correct answer is A. Therefore, the correct answer is option A.